AP Style Free Response Problem 4. For the reaction 2N2O5 gas produces 4NO2 gas plus O2 gas. The following data were collected. So we have time in minutes, concentration of N2O5 in molarity as time increases. A, what is the order of this reaction? B, what is the concentration of O2 at time equals 10 minutes? C, what is the initial rate of production of NO2 for this reaction? D, at a particular temperature, N2O5 decomposes according to a first order rate law with a half-life of 3.0 seconds. If the initial concentration of N2O5 is 1.0 times 10 to the 16 molecules per centimeter cubed, what will be the concentration after 10 seconds? All right, in part A, we're asked to determine the order of the reaction. So you can see that the concentration is decreasing with respect to time. So this is not zero order since the rate slows over time. If it's first order, the change in the natural log of N2O5 will be linear. For the first 3 times, that's negative or a decrease of 0.03, negative 0.03, and negative 0.031. That's close enough, so we would say that this is a first order reaction. I just want to remind you from your equation sheet, remember that the graph will be linear. Remember, we have natural log of concentration of A equals minus KT plus the natural log of concentration of A0. Okay, so this would be the equation for the line on the graph. If we plotted the natural log of the concentration of A versus time, we would get a slope equal to minus K. Now part B, what is the concentration of O2 at time 10 minutes? So the stoichiometry of the reaction tells us that for every 2 moles of N2O5 that react, 1 mole of O2 will be produced. In the first 10 minutes, 0.0032 moles of N2O2 reacts. So the change from here to here, 0.0032. It's a decrease of 0.0032 moles for every liter of N2O2 is reacting, which means half as much O2, 0.0016 O2 will be produced. So at 10 minutes time, the concentration of the O2, 0.0016 moles per liter. Part C, what is the initial rate of production of NO2 for this reaction? So take a look here at the stoichiometric relationship between the rate of disappearance of N2O5, which has a coefficient of 2, and the appearance of NO2, which has a coefficient of 4, right? So the rate of production of NO2 will be double the rate of disappearance of N2O5. So initially, what is the change from 0 to 10 minutes? From 1.24 to 0.92 is a difference of 0.32 times 10 to the minus 2 molar. So that's how much N2O is consumed. Okay. Then if 0.32 times 10 to the minus 2 moles of N2O5 per liter is consumed, and 4 moles of NO2 are produced for every 2 moles of N2O5 that are consumed, this would give us So multiplying by 4 and dividing by 2 is the same as multiplying by 2, right? So 0.64 times 10 to the minus 2 moles per liter, or molarity, of NO2 produced. Part D. At a particular temperature, N2O5 decomposes according to a first-order rate law with a half-life of 3 seconds. If the initial concentration is 1 times 10 to the minus 6, 1 times 10 to the positive 16 molecules per centimeter cubed, what will be the concentration after 10 seconds? So we need a couple of equations. We need the integrated rate law equation for a first order reaction. Remember, you have this on your equation sheet. So natural log of concentration of A at some time t is equal to minus kT plus the natural log of the initial concentration. And the half-life formula for a first order reaction, 0.693 over K. So the first thing we can do is calculate K, because we're given the half-life. So K is equal to 0.693 divided by the half-life, which is 3 seconds. And we get 0.231 inverse seconds for K. Once we know K, we can use our integrated rate law equation. So the natural log of the concentration of N2O5 at time t is equal to minus kT plus the initial concentration, natural log of the initial concentration of N2O5. So the time we're concerned with here is after 10 seconds. Okay, 10 seconds. So at time 10 seconds equals negative K is 0.231 inverse seconds times the time of 10 seconds plus the natural log of the initial concentration of N2O5, which is given as 1 times 10 to the 16th molecules per centimeter cubed. And those units are fine. It's just like moles per liter. It's a unit of concentration. And all it does is help us figure out our final units for concentration. So we get, let's see, minus 2.3 from this term and 36.8 from this term, which is 34.5. So the natural log of the concentration at 10 seconds is 34.5. How do we eliminate the natural log? Remember, you raise e to the power of on both sides of the equation to cancel the natural log. And so the concentration of N2O5 at 10 seconds is e to the power of 34.5, which is 9.62 times 10 to the 14 molecule per centimeter cubed.